So this section is actually a review of lots of things we've done before. So it should be pretty simple. It's just graphing different types of functions using the stat plot and the calculator and seeing which model is the best for the data. So there's a linear model, which makes a line, quadratic, which makes a parabola, exponential, which gets steeper and steeper, power regression, which is kind of like exponential, but not quite as steep. So those two, it's going to be a little bit harder to tell. And there's a cubic model, which makes an S. So these are the generalized forms of the equations. And basically what you're going to do is plug this stuff into stat and run one of these regressions. So linear regression, quadratic regression, cubic regression, exponential regression, or power regression. And it's going to give you all the variables except for x and y. So it's going to tell you a, b, and c, and you're just going to write it back into this formula like we've done earlier this year. So let's look at an example of how to do this. Okay, so it says the table shows each fish's length, x, in inches, and weight, y, in pounds. So we're going to enter all this stuff into stats. Press stat, edit, enter all this information. So 10.3, oops, 10.3, 15.2, all this goes in x, 16.2. All right, I've entered all the data in for us. And now we're just going to graph it. So we want to turn on the stat plot. So second y equals, turn on the stat plot. Make sure it's reading from the x list is L1, the y list is L2, then graph it. Of course, it's not going to see it, so you need to zoom stat, which is zoom 9. Now we can look at it. And judging at the data, we need to try to guess what type of model fits it. So it looks like it's a linear model, but this first point seems a little off. So we're going to try a few different models. And what we really want to do is find the best model that fits this data. So we're going to have to try a few different ones. So we're going to go to stat, calculate. We'll start with the linear model. And actually, judging from this, I mean, it might be linear, but since this point's off, let's try some of the other ones first. We'll say linear is what it's going to be if nothing else works. So go to stat, calculate. Let's start, to me it kind of looks like a power model, so let's start with that. And we're going to write this down. So it's y equals, and this times 10 to the negative 4 is very important. So 4.09 times 10 to the negative 4, that's 0.0004 x to the 2.91 power. So I took the value for a and put it where a goes, took the value for b, put it where b goes. Now I'm going to try to enter that and see if it works. See if it fits the data. Okay, if it looks like it fits sorta, but we can probably do a little bit better than that. We'll just remember that power model might be our best bet. Let's try one of the other ones. So really it's just trial and error if we can't tell. Let's try exponential. So this one says the formula is y equals 0.0687 times 1.19 to the x power. That's the exponential model. So we'll plug that in and see what we get. All right, let's just turn off this first line by clicking on equals, and we'll write it in the second line. Let's try that. Okay, and that model seems slightly worse than the first one. So let's try another one. One of the other things that can curve like this is going to be the cubic, or the quadratic, so let's try that. I know we can only see part of it, but let's just try it anyways. So we have y equals 0.0178 x squared minus 0.313 x plus 1.704. Let's try entering that. Turn off our second trial. Okay, it looks like that model is basically perfect. So we're going to go ahead and assume that this has a cubic relationship between the fish's length and the weight. So we're going to go ahead and assume that's our answer. That's the model that best fits the data. Then, of course, we can once we have this equation, if we want to find a certain weight, y, we can just plug in a length for the x values to get our answer for y. So once we have this equation, we can really easily use it to find information about other fish.